But before we talk about the actual equation itself, we need to dive into slope in general. Okay, slope, I know that we have a big background on this. What I say is change in y over change in x. Okay, and that's actually a triangle called delta that comes from Greek lettering. Delta means change in. So what you're doing is you're taking y values and subtracting them, and then x values and subtracting them. It does not matter whether you take the first y or the second y to start the equation. You just have to make sure that the x's take the same one. Essentially, that needs to be a point, and then this needs to be a point. Okay? Doesn't matter which order you flip them in. Okay? Uh, the big thing that you'll hear is rise over run. Okay? Rise over run. So, what really is slope? It's um, how quickly something is increasing or decreasing. So you might have a super steep hill, right, that you're climbing up, or you might have a hill that you're decreasing at a small rate, right? So lines in general, just talking about how fast or slow it is increasing or decreasing. So this is a part for today, 4 types of slope. Okay, there are 4. Okay, obviously, it's kind of based off of what I do, so you can have one that looks like this, which would obviously be a positive slope. So you are increasing, right? So it's positive. Make sure you always read the graph from left. Okay, so from left to right, it is going up, so it is positive. Versus one like this, where it is going down, so that would be negative. Now think to yourself what other ways that we can draw a line. Hopefully something that you're thinking of would be maybe a horizontal line, right? One that's straight across, okay? This is called the zero line, okay? So that your slope of 0, okay? And then you can have one that is obviously the opposite, where you are going up and down, okay? That is called undefined. So let's talk about slope-intercept form, okay? So slope is actually your m. So this is y2 minus y1 over x2 minus x1. Okay, it is your slope. Change in y over change in x. And then you have this b, okay? And that b comes from the equation y equals mx plus. Hopefully we can kind of take a little guess what b is from our prior knowledge, but that actually is your y-intercept, which is where it crosses the y-axis. Okay, so step number 1 would be to plot the y-intercept. Step number 2, move slope, which is rise over run. Okay, one little side note here. Remember that every point is x comma y. So you do need to move left and right before you move up and down, which is kind of the opposite when you get to slope, because slope is rise over run. So you're going up and down before you go left and right. So if we look at number 1, okay, again, following our 2 steps here, we're going to plot the y-intercept first. The y-intercept comes from our b value. So because it says +2, we're going to move up 2. Okay, we always start with the y-intercept, and that is your y-axis, right? Then we're going to move our slope. So if m is 4 over 5, that means we're going to move up 4, right 5, because they're both positive, so that means up and right. So we move up 4, right 5, plot our point. But you always want to go in the opposite direction if you can. So down 4, left 5, plot our point. Now, if we did it again, you could go into another spot like this. You don't have to. I'm okay with just 3 points. You need at least 2, but I would like 3 if you can fit it on the graph. Draw your line through it. Ugh, I hate when I do that. Hold on. There we go. So the same thing's going to happen with number 2. Okay, we start with our y-intercept, which is 5. So we would move up 5. From there, our slope is -2. Remember, every number is a fraction if you have a 1 in the denominator. And then now we can see the -2 means we would go down, but the 1 is still positive, so we would move right. So down 2, right 1, down 2, right 1. And again, I go a couple. Most of the time, I'll fill in a good amount just so that I can see what's going on and see where it's going. So a big part of this is so obviously we know this is a negative slope, so we should be decreasing, and we are, which is good. And oftentimes people go in the wrong direction because they'll move down and left. Well, moving down and left is the same thing as moving up and right, both the opposite ones. So just make sure that you're just making one of the numbers negative. So there's something different about number 3. Hopefully you're noticing there is a 6 supply. We would have to divide by 6 to divide. Now what I do is I make sure that I focus on dividing every single term by 5 or by 6. So we have y equals, well, -5 over 6 can't be reduced, so we just leave it. And then 6 divided by 6 is 1. Notice how I put the x right next to the 5, 6. You can keep x in the numerator, or you just move it off to the side. I would much prefer the way I. So again, we're going to start with our y-intercept, which is 1. So 1. And then we are going to move our slope, which is -5. So if our slope is -5, we would move down because it's negative, but right still because it's positive. So down 5, right 6. Okay, now when we go in the opposite direction, we would be going up and down, which means that we really are moving 5 or -6, up and down. Unless you can't move up and down at the same time. So up 5, left 6. Can't go any further without going off your graph, so we can be done. And again, this is decreasing, so we know we did it right. On number 4, not only are we going to have to divide, we also need to add 6 over. With slope-intercept form, you always have to get y by itself before you graph it. Then we would divide each term by 3, and you're left with y equals x, right, because they cancel, plus 2. Now notice how my x is first. It really doesn't matter whether you have y equals x plus 2 or y equals 2 plus x, right? You just have to be careful because that just means that your b value is first. Okay, this is just y equals b plus mx. Okay, it's the same thing, so don't let that confuse you. So again, we start with our b value, which is our y-intercept, and then we move our slope. If there's no number out in front, that means it's a 1, and 1 over 1 just means up 1 over 1, over and over again. Okay, again, I like to go all the way through my graph just because it's more satisfying for me. This one's easier because you can kind of eyeball exactly where it's supposed to go. Um, just be careful. You want to make sure that you put at least a couple, not just a line and then don't tell me where it's going through. All right, then this part we're going to actually write an equation. So I encourage you to pause and try to do it on your own first, and then listen to my explanation. Same thing's going to happen on number 6. So I know it's going to be y equals something x plus or minus something, right? So I know it crosses at 4 again, so it's going to be plus 4. Now this time if I make the triangle, I go down and right. Down is negative, so I need to go negative 4, and then I move right 8. Oh, why did I still write a 4? I don't know. So at this point, if you have this as your final answer, you're going to get most of your points, but hopefully we notice that this can be reduced. If you divide both by 2, you get negative 2. Actually, if you divide both by 4, you get negative 1 over 2. That means we could have moved down 1 over 2, down 1 over 2, and so on, instead of using the 2 points that they have. Next one says a line that has a slope of negative 2 and it goes through 1, 6. So I don't know what the y-intercept is, and you do have a couple options. Right now they show a graph. So you could plot 1 and then 6. So I know it goes through that point, and I know my slope is negative 2. So if I start at that point and go down 2 over 1, I could keep going and graph it, right? If I go in the opposite direction, up to left 1, I can clearly see where it's crossing the y-axis. Because of this, now I can do my line, which would be y equals negative 2x plus 8. Number 9 says a line that crosses the x-axis at 7 and the y-axis at negative 5. So I'm going to go ahead and plot those. We have the x-axis at 7 and the y-axis at negative 5. Now, if I know it goes through those 2 points, first off, I have the y-intercept, and I can find the slope by doing rise over run. This goes up 7, right 5. So my slope would be 7 over 5. So putting together, y equals mx plus. Notice how all of my equations have a y and an x in it? You can, like we showed you up here, plug in for y and x, but your final answer should have them as y and x. At this point, we're going to talk about a couple word problems. So it says Greg is driving a remote control car at a constant speed. The car starts 5 feet away from Greg and travels at a speed of 4 feet per second. Okay, this per second tends to talk about rate, which is the same thing as slope. Write a linear equation to find the distance of the car, y, from Greg over time, x, in slope-intercept form. So we know it's going to be y equals, and then our slope, which again, if you're talking about any kind of per second or per something, that's going to end up being your slope. And you start 5 feet away, so that would be your b. Now it says use your equation to determine when the car will be 35 feet away. Okay, so this 35 feet away, we are trying to plug that in for one of our variables. Notice how it says that y is the distance of the car from Greg, and then time is your x. So if you're plugging in 35, you would be plugging it in for distance, which would be your y, not time, which is your x. So we have 35 equals 4x plus 5. We would subtract 5, get 30 equals 4x, and then divide by 4. At this point, most of the time so far, I've told you to just keep it as a fraction, but because we're talking about time, we can go ahead and actually divide it. So x would be 7.5, okay? And that's because we're talking about per second. So it would be 7.5 seconds.